Hi, my name is Nitin Tiwari. In identity and access management administrators are bogged down daily by a massive volume of repetitive tasks like handling password resets, manually provisioning and deprovisioning users, or troubleshooting multi-factor authentication issues. Right? These are some to name, but there are a lot more. At the same time, they're expected to drive high value projects. Like there must be a roadmap in the enterprise to onboard new applications and integrate them via SAML, OIDC. All this while facing a constant pressure to monitor and mitigate risk from a constantly evolving threat landscape. This routine workload takes a massive toll. According to a data from Deloitte's Cyber Risk Services Research or EY's report as well, right? Access management administrators lose roughly around 20 to 23 business days a year entirely to routine and manual tasks. That's almost a month of productivity in a year. I have developed an Agentic AI designed to seamlessly integrate into the flow of access management work, augmenting and accelerating how administrators handle these exact challenges. Today, I'll show you a live demonstration of how this AI can transform the AM operations using Okta, a global leader in access management. Here is what we'll cover in this video. A quick glimpse, a fast preview of the working agentic AI in action, a detailed use cases where we'll discuss and show a deep dive into the real world admin scenario, integration overview and code walkthrough, like what's the integration patterns, what are the systems involved, how it is flowing through, and what is the enterprise grade mechanism around authentication and authorization, and how the system is built and wired together. Then we'll have a live run, running the code and to demonstrate additional use cases. And then finally, we'll talk about very briefly where this technology is going, the marriage of AI and identity and access management, along with some critical limitations and design considerations that one should have for this current implementation. Hope you enjoy it and learn from it, and hope it's valuable. Let's dive in. So what you saw just now is a quick preview of the agentic AI where we pulled all the Okta system logs by just connecting with the agent and recover those. And that too by just writing one or two sentences in a chat. So let's take a look at the agentic AI bot. Let's open it. So I have run the required servers to run this agent before this already, which I'm also going to show later in the code walkthrough. The agent opens and asks for device authorization, which infuses security, and you could also manage it via roles. Let me just do that right now. I think my user has a session, else it would sometimes ask me to authenticate via username and password as well, including the Okta Verify token. If you stay away from the bot too much, it might ask you to authorize again between the gaps of chat for security reasons. Okay, let's take a look at our users. Let's talk about the specific complex scenario and users we are going to accomplish or primer this specific demonstration. We'll be using these three users. The first one, Satyajit, is a regular user, and two other, Bob and Joe, are the user we will use to show attackers who are detected to have large number of unusual login failures
And through this demo, we'll show real-time threat detection and remediation via the agent chat. And that's gonna, kind of show the agentic part of this whole exercise. For Bob and Joe, we'll prime the Okta system logs by doing their login failures when on VPN. Um, let's also take a brief look into Okta admin console, which I have opened already to show you these users. These are the three users: Satyajit, Bob, and Joe. Now I'll open the VPN. I have Turbo VPN, which gives me daily free credits on my Mac. Let's connect. I see that it's connected to Singapore. Okay, we are set for the next step to emulate the failed login scenario. I'll go to the Okta end user portal now. Let me quickly do 4 to 5 times wrong password login for this one user, Bob. I think we should be good. I'll leave Joe for right now because if it happens for Bob, it will also happen for Joe. I'll show you that later on as well. Now let's go to the agent and do the real stuff. See, I told you the agent times out and we have to do the authorization again. Let's do that. It's connecting to the Okta again and we are connected. That's good. Now let me ask this. Hi, can you show me the failed sign in attempts from the last 1 hour? Include the username, source IP, and location. Let's see what it returns. Okay, it is returning multiple users, which is fine. My admin user and the Satyajit user, which are the kind of correct users. I may have mistakenly put the wrong password before this demo, so it's coming there in the logs. But our actual users, which should be coming in any case, is Bob and Joe. Imagine if this list was huge. Right now, I have a trial tenant and limited users to emulate this.
Here are some failed sign-in attempts from the last hour. 1. User, Satyajit Ray. Source IP, 223.181.
So let's ask it something else, right? Can you tell me which country they are originating from and which country looks suspicious to you?
The failed sign-in attempts originated from the following countries. 1. India.
See, it gives
Attempts
some
from
idea of
Bengaluru.
principle that I
2.
should be having the
Singapore.
idea that where the user generally log in from in terms of place of business that this tenant is being used for, and it is also kind of detecting the Bob user doing the failed password malicious activity scenario on VPN, which we did to make it look via Singapore, right? So it is detecting that as well. So now we've got an idea that something is fishy with Singapore. So let's ask it few more things, like something more technical. Find the sign-on policy rule which kind of controls the Singapore access. Okay, it says that there is a sign-on policy that might control the access, and it finds it for Singapore, but it's not sure because it's not able to find the geographic condition because that's not exposed by the Okta APIs, right?
There is a default sign-on policy that might control the access for users from Singapore. It does not explicitly mention geographic conditions, so any such conditions would typically be defined in specific rules under this policy. If this policy controls access to Singapore, check for rules applied to locations
So
or IP
yeah,
zones
so
to ensure they are configured
let's see the details of the rules in it. Can you show me all the rules in the default sign-on policy? So it showed me, right? So there's already one block zone wise, which I created before. And so
Default
yeah,
sign-on
we have
policy
exclude
contains the
users and
following
default rule,
rules.
which are already
1.
there.
Block zone-wise. Access, deny. Network condition applies to
Okay, let's
specific.
pause it. Can you activate block zone wise? This should block the users trying to access from Singapore.
The block zone-wise rule has been activated successfully. This should block users trying to access from specific network zones, such as Singapore, if configured in those zones.
And yeah, it just did it in less than 5 seconds. And now what I'll do is I'll go back and disconnect the VPN because I want to check my normal user, which is accessing from India, is able to log in, Satyajit. Right? And yeah, Satyajit is able to log in. and I sign it out. And now let's check the main users from Singapore. So I go back to the VPN, connect again, it's connected to Singapore. So that's good. Let's try. This is the main thing. Joe Simpson. Yeah, see, it said you're not allowed to access. The resource owner authorization server has blocked. We'll try the same thing with Bob. It's actually Bob, which we had done multiple failures while we were on this video. So even he's not allowed, right? So both Bob and Joe um, used to simulate the attack. I showed in the video only Bob, but Joe also I had done. So both are not able to log in, and that is what we wanted. And this is the power of agentic AI that will finally, kind of bring the transformation. And what we are trying to understand here is that how these transformation will come in the identity and access management world. So one of the areas that which we are seeing currently right now, or we are at least saying that it will bring a big transformation, is the access management administrations and even identity management administrations. After this, I'll also, kind of quickly show you a quick create user, so that, just to give a quick flavor. We'll just quickly run through it, and then after that we'll go into the architecture design pattern of all the components that are making this possible.
Let's see the architecture that makes this agentic AI on Okta possible. On the left, we have the body. This is our agentic interface where the human context lives. At the top, we have the brain, the large language model. Its job is purely reasoning. It understands intent, but crucially, it has no hands. It cannot touch our production environment of Okta. That brings us to the center, the yellow cylindrical piece, MCP Server, also known as Model Context Protocol Server, the hands of the operation. We are using a standardized connectivity layer, also sometimes known as USB-C of AI. This secure gateway translates the AI's reasoning into precise structured API calls. MCP's open source standard was developed and released by Anthropic in 2025. Next, you see on the right of the yellow MCP server, I have configured this layer to use the device authorization grant with Okta. This means the AI isn't running loose. It is authenticating interactively on my behalf, ensuring that every action, from looking up the logs to unlocking users or blocking entire IP zones, adheres to strict IAM governance. Let's see it in action. To start understanding the flow with all the participant systems that are shown here, let's trace the lifecycle of a single request in this new agentic world. It starts with the ask on the left on the agentic AI based bot. I prompt the agent to unlock a user or anything else which you normally do in access management, something like, say, suspend all the contractors group users who have not logged in last 60 days, something which is often mandated by compliance across enterprises. That request moves to LLM along with definition of what tools are available. The LLM doesn't execute anything, it simply plans the best course of action. It sends that plan to our MCP server in the middle, the yellow box. This is the critical piece, like I was saying earlier. Instead of writing custom brittle code, we use the universal connector to act as a translator, the MCP server. It takes the AI's plan and convert it into secure RESTful API call to Okta, shown here on the right. Crucially, because I am using interactive device authorization, grants, the system maintains the context of who is asking. The response flows back through the bridge, is synthesized by the LLM, and presented back to us as a completed task. That is, the user is unlocked. Imagine a user can't log in. An admin typically has to search for the user, check the profile status, navigate to system logs, filter by the user, decipher cryptic error codes, and go back to the user profile to reset factors. The agent I developed in concept here, based on this integration pattern, just turned that 15-minute investigation into a 30-second conversation. And that's pretty good, and that's where the future lies. What you are looking at here is the future of identity operations.
Traditionally, we rely on humans to bridge the gap between I need to fix this and the specific buttons in Okta dashboard, which can become cumbersome and time taking. In this architecture, we replace that manual friction with the integration pattern. What do we mean by that is that we use LLM for reasoning, the brain, but we isolate it from our infrastructure using this yellow block in the center, our MCP server, which are the hands. Think of this middle layer as a firewall for users' intent. It ensures that the AI can only execute strictly defined tools, like read logs or unlock user or remove group or whatever Okta is wanting to expose, but nothing else. Like I said earlier, I've configured Okta tenant integration run interactively via device auth. It creates temporary secure session that acts as an extension of my credentials. It allows us to leverage the speed of AI without sacrificing the controls required by the tenets of the access management. There's also an option of headless system to system authentication mode. Instead of prompting a person to log in, the server authenticates using cryptographic key pair. But I use interactive device auth to show more clearly in this video. But system to system authentication is more suitable for production or enterprise grade systems. I hope this helps you to understand the integration, and in general you understood how the agentic AI will or can or should integrate with identity and access management systems and where the future will lie. Okay, for the code base there are two sets of code bases, front end and back end. As you can see, I'm using VS Code, I'm using Python environment Python 3.10 plus and UV for Python package management. Here how the project looks. First code base, which is under the project root, is the bot agent framework implementation where I'm using Chainlet's Python based framework. Chainlet's documentation is decently comprehensive to guide you on the various flows and their respective actions. Chainlet or Streamlet are good for quick demos or experimentation, but not for production grade application, and there are numerous other frameworks available for that. So this is the front end. Here is the app.py which we will run when we will start the UI after starting the MCP server. Here you have to define various chat events, and of course connection to the server has to be made. Here is a copy of the environment variable file which the agent uses. It has details of Okta connections and the LLM secret. For Okta connection, we have created an application for the standard protocol server or MCP in Okta. Basically to get authenticated for secured connection, and the API scopes are defined in that application as well. We'll see that soon when I will show you the application created in Okta. Second code base is the model context protocol which is residing under this folder. It has to be run as a server to act as a bridge between agent/LLM and Okta. This is the yellow box we saw earlier, acting as a secure mediator between agent and Okta. Remember, LLM is only speaking with agent, not to Okta. That is important. Let's run the standard protocol server or MCP first, and then we will run the agent app. I have the windows open in terminal for both UI and server. Let's run the command to start the MCP server. After you start the server, it triggers a prompt to log in via your browser. Here the MCP server exchanges your browser login for a secure token that it can use to communicate with Okta APIs. Let's also see the server logs for confirmation. I think we are good here. It authenticated successfully. Now let's see the specific application I have created in Okta for the server to communicate with OIDC OpenID Connect as the sign-in method. Let's log in into Okta with password and Okta Verify for the second factor. Here's the application with its details. Let's see the sign on tab. The various API scopes that I have enabled for this server. And this is where an enterprise or administrators of the Agentic AI can have a granular control. If you look here, I have enabled the user management, policies, group management, etc. related scopes. If you look at this one, okta.policies.read, I had not added it initially, and when I had asked a question on authentication policies to the Agentic AI bot, the agent said it did not have permissions. So then I had to enable it here and also mention in the .env file for the codebase to know that the agent has permissions on it. Now let me start the agent app. It will open the agentic bot in a browser tab. See, it is trying to connect to MCP, which should prompt me automatically. Here it is. In another tab for device authorization, and if the session is not there, it will ask me the login Okta verify as well. Let's do that. Also, let me show you the logs in VS Code for the UI that we started, because the browser popped up in between. Let's take a look at the logs. See, besides the usual, it talks about the device auth initiation that happened and we completed and its success. Now let's go back to our Okta agentic bot. See, now we are connected after the we logged into the Okta and completed the second factors, and this is great. See the top, it is printing the successful connection to the Okta, else it would have shown other messages like not able to connect messages. Let me ask, say a simple hi and ask what you can do. Here it is. Yes, it has voice too. Not from the user's input, but agent's output side. That's not a big deal to quote.
Hello, I can help you manage your Okta environment. Here's what I can do. User management. List, create, update, deactivate, and delete users. Group management. List, create, update, and delete groups. Manage.
Now let me ask about a group I have created in Okta for this demo. Is there any group related to engineering or something in the Okta? I need to check the users who have not logged in, say, last 3 days. Let's see what it returns. There were two users in it.
I found a group related to engineering. Engineering. This group is described as group.
For senior engineers and engineers in organization. Let me check the users who haven't logged in within the last 3 days. In the engineering group, I found the following users who haven't logged in within the last 3 days. 1. Henry Ford, email henry.ford@charnier.io, no login recorded. 2. Charles Babbage, email charles.babbage.io, no login.
I have Okta opened up showing the same group. Let's see. There are the same two users. Good. Till now we have got info, but not the feel of agentic. Let's try one more thing. Let's make a context say something like, hey, I need to deactivate user with the name Charles Babbage immediately because of some request from the concerned manager / HR in his team. Let's see. Okay.
Charles Babbage has been successfully deactivated. Let me know if there's anything else you need.
Let's check in Okta if Charles Babbage got removed. Yes, and great. This is what the agentic AI and IAM will feel like. Imagine this happening for routine tasks where admin have to do cleanup for, say, contractors who haven't logged in last 60 days and things like that. Of course, as the AI and corresponding agentic world is evolving, this is just gonna be better. Again, I think this is awesome in terms of any person who is into administration to have the ability to administer tasks, operations via chat or voice enabled via any LLM's brain. We are using GPT here for Mini specifically. I am using, but you can use any other like Anthropic's Cloud, etc. Summary in terms of future and where this is going, right? Few of the things let's discuss, like conversational IAM administration. That, of course, that is very much plausible and it is a near-term possibility that will actually happen. Admin tasks will become more chat-driven workflows. As one would be able to generate user access reports instantly, modifying access without navigating consoles, bulk operations via natural language. Today, most access management work is still console-heavy and ticket-driven. The next areas that we will see in terms of evolution will be automated access governance operations. So, like one could do policy enforcement and remediation through AI agents. Beyond reporting, the agent would be able to deactivate accounts, enforce MFA policies, or update group access, and can move from manual operations to governed AI-driven workflows. Lastly, I think Real-time identity threat response. This is where I think things will get truly transformative. I know real-time threat response has been a holy grail of cybersecurity, and especially now, identity is now the primary attack surface in most breaches, right? So think like this, right? AI will interpret the identity signals. These access management and identity management systems are generating a lot of identity telemetry data, and kind of AI will interpret those signals and orchestrate the response, right? It can interpret suspicious behavior and respond immediately, probably enforcing step-up authentication, suspending sessions, or isolating compromised identities before humans can intervene. Of course, agentic AI won't replace IAM platforms. Overall, I think it will redefine how we operate them. What we would see is a shift in IAM world from reactive administration to proactive identity security operations using AI. At least that will be the beginning of AI transformation in identity and access management. There are few considerations and limitations with the current implementation. I've grouped them into AI related limitations and platform or architecture considerations. First is the context window limitation of the LLM. Large enterprise environments can have thousands of users, groups, and policies. So sending everything to the model isn't practical. Typically, this is mitigated using techniques like vector retrieval or RAG, retrieval augmented generation stands for, where only the most relevant information is retrieved and passed to the models. The second consideration is LLM hallucination. Like most generative models, the system may occasionally produce responses that sound correct but are not fully grounded in real data. This is usually mitigated using guardrails, structured API responses, and validation layers. For structured API responses, what it means actually is that whatever tool you are connecting your AI with, right, if it is giving you a structured API response, like in our case, it is Okta, which is giving us a JSON structure, you don't convert that JSON structure into natural language before you pass it over to the AI. Another important aspect is observability and governance of AI decisions. Enterprise need visibility into prompts, responses, and actions performed by the agent. This is typically handled through logging and monitoring platforms. We all have seen Splunk, and kind of in our IAM architectures of enterprises, Splunk also provides capabilities on AI agent monitoring. So kind of one can use similar observability systems. Moving on to the platform and architecture limitations. From a platform perspective, the MCP server integration is currently in beta. So what it means is that the MCP server code that we have incorporated in our code base is released by Okta, and Okta has marked it as beta. So there is some sort of risk that comes along with it. So one should be judicious in using it. But of course, the APIs and capabilities may evolve over time. The next one is Chainlit Prototype UI. The current interface that I have built is using Chainlit, which works well for rapid prototyping, but production deployments would typically use more scalable web frameworks, something like React, Next.js. The sixth one is security. Because the agent interacts with identity systems and potentially privileged operations. So of course, like every other, kind of identity and access management or privileged operations handling systems, in production environment, you would normally implement role-based access control and approval workflows. The last one is the Okta API rate limits. In fact, any system that IAM system that you are integrating with your agentic AI, that system's API rate limits, because interacting with identity and access platforms are subject to API rate limits, we all know. And thus, it also affects the performance. So large scale environments may require caching or batching of requests. Overall, while this prototype demonstrates the potential of agentic AI for identity and access management systems, production deployments would require additional controls around scalability, governance, and security. Again, reiterating that whatever considerations and limitations that I have given here for the agentic AI integration with Okta is also applicable to any other IAM system that you would configure, like IGA system, privileged access management system. They would still apply as they are shown here. Yeah, that's it. Thanks.